Donc, I'm going to switch to English for this one since we have people who doesn't speak French, and the French people will say they don't speak Quebec French as well. So we'll try to do it in English so everybody's going to understand. Alexis Achim abstained. Well, first of all, today we have a presentation from my colleague Alexis Achim from the University Laval. University Laval is where I did my studies as well, so I know pretty well the place. This is where I'm from as well because I'm from Quebec City. So nice institution, not as cool as Sherbrooke, but still a nice institution, of course. So I'm going to present you Alexis, then I'm going to leave the floor to him for his presentation. So he obtained his degree in forest management from the University Laval in 1998. He then developed research interest for the impact of forest practices on the property of wood supply and obtained his PhD from the same institution in 2004. So basically, I think we were in the same dates or in the same area at the same place, Alexis.
Yeah.
From 2003 to 2007, he worked as a wood scientist in forest research, the research agency of the British Forestry Commission. He was hired as a professor at the University Laval in 2007, where he has developed a research program on the link between silviculture and wood properties. In 2017, he was appointed as the director of Laval University Renewable Matériaux Research Center, and since 2019, he's also been leading Matériaux Renouvelables Québec, an innovation network aiming to foster collaboration and facilitate knowledge transfer in the field of renewable materials. And of course, we are part of this network with him as a leader, and so far leadership has been good. So that being said, I will leave the floor to my colleague Alexis Achim.
Thank you, Jean-Michel. It's a real pleasure, and I wish I could have been with you guys in person. I am very much looking forward to visiting the coolest lab of the coolest university in Quebec. In fact, I hope, as I was saying in French just before, I hope that I can visit. I think we have common interests, and also we have compatible labs. And this will be the main story of my presentation today. So just to get going, is it switching? Okay, so the career outline is already being given, so I'll skip this. This is part of my research team. About half of my research team, we have a lot of fun working at the interface between forest management and wood processing. And so this is the kind of presentation I want to bring. I want to try to make the link between forest management and wood processing, but I'd like to go a bit beyond what my group is able to do in general. And of course, to go beyond, we need new collaboration, and we need to foster our ongoing collaborations with you guys. This is the Renewable Materials Research Center. In short, this is the group of people that work in wood science in the Kruger building at Laval University. That's where Jean-Michel is from. We have we have 13 regular members who are professors, and about 10 technicians and 10 more research associates and administrative support. And all of these professors, they have about 50 to 60 plus grad students, postdoctoral fellows, and whenever before the confinement, we were all in the Kruger building, and now it feels really empty, but our lab facilities are still being used. And so we have the grad students that, as I was explaining to Marie, the grad students who are doing measurements in the lab, they are allowed to come in. But it's certainly a very strange time at the minute at the Kruger building. Those are the labs. Just so we have a pretty large facility, mainly dedicated to the processing of solid wood. So that's the bread and butter, I would say, of the research center, is the processing of solid wood. We do have other areas of expertise. but really our main strength is in processing of solid wood. Let me just switch. So what about the forest management context I was talking about? The main make here in terms of forest management is that things are changing very rapidly, and forest management at the international scale is facing incredible pressure, both social and environmental pressure. So of course there are some spectacular events, just as the fires on the West Coast that disturb forests, and that in some cases can even question the relevance of having a forest value chain in some parts of the world. So that's very disturbing. This is the case for the West Coast, but in Quebec also we do have natural disturbances. Fires are common. They're the most frequent source of natural disturbance to forest. There's other disturbances. In this case, we're showing a blowdown, a wind throw of trees due to high winds. We also have, perhaps more importantly, we also have pests and diseases that will tend to affect forests in ways that are maybe not as spectacular, but that will target given species and basically make them completely unusable. So this, what I'm showing here on this picture, is an example of the beech bark disease, which is slowly but very surely depleting completely the beech forest resource, killing trees. And what's even more worrying is that it triggers the regeneration of the very same species, which is going to get again attacked by the disease when the tree gets older. So this is an exotic disease that's been affecting our forest. Much less spectacular, but large volumes of beech. In your area in Sherbrooke, the beech is, if not already dead, is often severely affected. So this is a case throughout Quebec, and so it means we have a lot of biomass that can go to waste. I'm talking here about the beech bark disease, which is carried by an insect, but we also have native insects such as the spruce budworm, which is currently in an epidemic stage, currently affecting mainly balsam fir as a species and killing millions and millions of trees at the scale of the province. So we have a lot of biomass in the form of dead trees throughout Quebec, everywhere. We do also have, of course, healthy and living forests that grow. And so what I'm showing here is the annual allowable cut. That's the amount of wood that the forest estate. So we're talking about the public forest estate. So Quebec has 90% public land, in which the chief forester estimates the biological capacity of the forest to produce wood. And so here what we're showing is that since 2008 there was a decrease in the estimated biological capability of the forest to produce wood in the after 2008. But since then, the amount of wood that's been produced by the forest yearly is about just over 35 million cubic meters per year. So this is the limit of the sustainable harvest that we could apply in Quebec. Now, the key thing here is not to try to get all these numbers, but on the left-hand side, when you see SPF-L, those are the conifer trees. They represent the bulk of what the public forest estate produces. Of course, the public forest estate is more located in the north, so that's normal. But what's more important than the biological capacity of the forest to produce wood is the wood that we actually harvest. So here, what we have from a recent study, we looked at what's the proportion of the allowable cut. So that's the biological capacity. What's the proportion of the biological capacity of the forest are we actually harvesting? And the thing to notice here is that for conifers, I don't know if you can see my mouse. Can you see my mouse when I point on the screen?
Yes.
Great. Okay. So for conifers here, what we have is a rather high with regional variation proportion of the biological capacity of the forest to produce wood that is actually harvested. But for hardwoods, you can see that this is much lower. And I'll come back to that. But for now, let's just say that for hardwoods, we leave a lot of production behind. So what's the issue then with forest management? In terms of dead trees, what we have is here is what we have to realize is that after a fire, those trees, they do not go up in smoke, right? A forest fire is very spectacular, but in most cases, what actually burns is simply the crown, and the bark or parts of the bark gets damaged, and the wood can get charred a little bit, but in reality, it remains available for processing. It can represent an issue. So of course, it's an important part of the forest ecosystems as well. So dead trees, like what you're seeing on this slide, are a key part of the ecosystem for various wildlife species. But with the increase in natural disturbances, what happens is that we get a lot of these forest stands being disturbed, and the biomass ultimately, if we look at it from a processing standpoint, goes to waste. In a case where we have a fire, you can see in this forest we have jack pine that's naturally regenerated in that forest. But in a lot of cases, we actually need to go and replant the area so that we avoid deforestation. So we need to go and plant some trees. And of course, if you have a lot of dead trees standing there, it's going to be very complicated to go and plant your trees. So in some cases, you want to keep recently disturbed forests as part of your ecosystem, but for other or in some cases, what you will want to do is to come and salvage this wood before it's too late. And this is the key message here, is before it is too late. So here you can see that it's probably too late. And why we can see that is you can see that the bark is peeling off those trees. And so we have made studies in which we've characterized what we call the shelf life of dead trees after harvest. So the shelf life, what we mean is when a tree goes from being live to being dead, for a few years, it will remain available for processing. It will remain of a sufficient quality for processing. And of course, if we wait for too long, then eventually the bark will peel off. And so we have stages like that that have been described from, those are called the hunter classes, from live trees in Hunter 1 to dead trees in Hunter 3, and Hunter 4 would be the dead trees with the bark peeling off. And through various studies, what we found is that, in short, when the bark peels off, the tree is no longer good for lumber, right? So if we are trying to process, to harvest saw logs that will go to a sawmill to be processed into lumber, and then the co-products will be sold as chips for pulp, or sawdust for pulp, or bark for bioenergy. Well, if the tree, if we've waited for so long before salvage operations have made, and if the tree is in a state where it's lost its bark, the value will be too low. So what you see here on the left-hand side, well, on the y-axis, you have the lumber value of all the boards in a single tree. And dBH here is the diameter at breast, the diameter of the tree stem at 1.3 meters above the ground, which is a reference height in forestry. So what we can see here is that in the case of Hunter 3 trees, those are the trees that are recently dead and have maintained their bark. There's a loss of value, but it's still, in most cases, you can still make profit by processing those trees for lumber. In the case of Hunter 4 trees, those that have lost their bark, then you have a situation in which the processing for lumber is no longer profitable enough to justify harvesting. So now we have a visual sign. So for lumber, if I come back to this slide, for lumber, this is no good. But this could be valued in other ways. But the question is, for how long will the trees maintain conditions for which in which they could be valued for lumber? And in another study, and we've run various studies on that, but this is an example. The answer to that question is about 4 years. So in boreal conditions, if a tree dies from any given disturbance and then starts to degrade, decay, it will take about 4 years before the assortment of lumber products becomes of too little value to be profitable, for the operation to be profitable. So what you can see on this graph, let's take black spruce, it's easier. So the study was conducted in 2007. So the trees were live in 2007. And we had trees that had died from a wind throw event from 2006, another wind throw event from 2003. And look at the difference between the highest quality is the select structural lumber here. And you can see that in this, between 2006 and 2003, we had a big decline in the proportion of the highest grade of lumber that was produced. So we were starting to see color and decay that would downgrade the lumber to a state where it's much less valuable. And if we were waiting 7 or 8 years, we just didn't have any of the highest quality lumber, and we had basically stuff that could not be valued for construction. So that 4 years. So we have a limited window of opportunity to harvest and salvage wood, a huge amount of biomass that's being created for lumber. In the field, what happens is that, so if it can happen after fire, it can happen after wind throw, and this is the case after spruce budworm. So in the field, what happens here is that we had a clear cut, and in the clear cut, you had a machine that went and harvested the wood. It was called, that's what's called a harvester. So it processes the tree stem into the logs on site. And as you can see, the minute it could see decay inside the stem from the spruce budworm affected trees, what the machine did is simply leave all the timber on the ground. So huge amount of biomass that in this case is actually harvested, but it's wasted because of a lack of quality. So it's not been salvaged in time. And I don't know if any of you guys have been driving through the North Shore of Quebec. Now we're starting to see attacks also in Ontario, in Gaspésie. There are some in Ontario as well, but there's some in the Outaouais region as well. But the North Shore has got the most spectacular case of the spruce budworm epidemic going on, and you can see a lot of dead balsam fir throughout the forest. So it's not being salvaged. When it is, there's a huge amount of or a huge proportion of the wood that's actually left behind because of a lack of quality. Again, lack of quality for what? Lack of quality for lumber. So as a sawlog, this is not valuable. So that's why it's left on the field and it's completely wasted. You remember this slide? So this slide was about the proportion of the allowable cut, the annual allowable cut that is actually being harvested. So let's get back to live trees in this case. So we are back in live trees, and we can see that again, we are leaving quite a lot of the potential production that we have in the forest. Now, is that a problem? You could argue that it's not a problem, because that means that the forest, we are not harvesting too much, and from a forest management standpoint, we could argue that it's actually good, because the forest will produce more than it actually loses, and so that leaves some space for natural disturbances, and actually the forest estate is probably gaining more volume as we are advancing in time. So that's one point, yes, but in reality, what do you think we target first? And I think that's the key part of my message here. What do you think we target first? Of course, what we target first is the most valuable stands, and the most valuable stands mainly for lumber, right? So gradually, what we are doing in areas where we harvest a low proportion of the allowable cut, what's very likely to happen is that the economic conditions for the harvesting are not good enough. So what will happen is that we will harvest the stands, the forest stands, or the trees, which have the highest value, most often for lumber. So what do? We actually, we create a bias for forests that already have sufficient quality or desirable characteristics. And what happens is that for a large part of those forests that do not necessarily have the good economical or financial conditions, we leave them behind. If we leave them behind, if we always use the low-hanging fruit, what's going to happen over time is that all our fruit will become very high and difficult to harvest. And if we look historically at forest management in Quebec, especially in hardwoods, and you can see that for hardwoods, the proportion of the harvest is rather low. So especially for hardwood, there's an unfortunate history of depletion of the forest estate over time due to a bias towards high quality timber. Now, let's look again at this map, and look, there's this important regional variation. So each of those areas that you see on this map, they each represent forest management units. Those are the units in which in our forestry system, we try to ensure that each of those little polygons, they will be managed under sustainable harvest principles. So basically, we do not harvest more than the forest than the biological capacity of the forest, and very often it's less. So this varies a lot from region to region, and what's important here is what we found in a recent study, in the same recent study actually, is that a key part to explain the proportion of the harvest that's being, or the proportion of the allowable cut that's being harvested, a key element is the distance to the pulp and paper mill. And now, very importantly here, it's not only the distance to the pulp and paper mill, but it's actually the distance to the hardwood pulp and paper mill, right? So this is for all species, including softwoods, the one key element that will explain whether we harvest a high proportion of the allowable cut or not will be the distance to the hardwood processing mill. And we can see on this graph also is that the local road network, if it's more developed, then there's a chance that it will be higher than if the local road network is less developed. So in your case in Sherbrooke, you are in a situation that's ideal. You're in the middle of privately owned land. So there's other issues related to that, including the willingness of owners to manage the land. But for those who want to manage their land, the main asset for the Eastern Township region is that you have a big pulp mill, which is a Domtar mill, that takes a lot of low quality material and processes that into a value added product, which is the fine print paper that they produce and other products. And so here, even for conifers, the distance to a hardwood pulp mill is key to explaining, is one of the keys to explaining the proportion of the allowable cut that will be harvested. Another key aspect in the same study was also the proportion of mixed forests. So the more hardwoods there are in a region, the lower the proportion of the allowable cut will actually be harvested. So again, let's go back to the field. Let's go back to the field, this case in the Gaspésie region, where we are in a situation where we have a lot of those mixed stands, and we are far from a pulp mill that could take the trembling aspen and white birch that are available in the forest stand. So what happens is you have clear cuts like this, where again, so we have had this machine that went into the stand, that harvested the wood, and that left those, in this case, trembling aspens behind, but you have that left the hardwoods behind. So they are harvested, but they go to waste, quite simply. And of course, in this case, you are left to wonder, what could we do with this biomass instead of wasting it? So the issue, in short, if I conclude on the issue in terms of forest management, is that, well, first, the search for high quality timber, it is the driving force of forest management. And this creates a bias for high quality timber for traditional products, like especially lumber, but also to some extent pulp. So this implies that low value forests or trees, depending at the scale at which you look at, are often left behind. That's what Evelyn Tifo, my colleague from the Renewable Materials Research Center, she calls them the unloved woods. And over the long term, as I was explaining, this leads to depletion of the forest estate. So for me as a forest engineer, I'm very worried when I see that the part of the allowable cut that will not be harvested is very likely to be that which has the lowest value, because over time this means that our forest estate is also of a lower value. I wouldn't have any problem with harvesting 50% of the allowable cut if we had unbiased selection of stands, and if we were able to manage all these stands equally well, provided, of course, that this answers the needs of processing mills and of the society in general, right? What I'm worried about is that currently there is this bias, and that I can see over time the forest estate being depleted of its highest quality forest stands and trees. Natural disturbances in this, they tend to exacerbate the problem, because they do create sources of biomass that will rapidly downgrade over time. And as they downgrade, they become more difficult to process. And if they become more difficult to process, they become also more difficult to, well, they also have a higher tendency to go to waste. And so, in short, we need value-added processing pathways for our so-called unloved woods. So how can biomass be used as a solution? Here, let me look at two cases. The first case is hardwoods. So two things to notice here. I'm in the field again in hardwood stands. Very often those hardwood stands, for reasons that I will skip here, are harvested not through clear cuts, but through partial cuts. So that implies selecting trees that will be harvested and trees that will be left behind. And of course, that implies a choice. When you make a choice, you can make a good choice or you can make a bad choice. And you have to balance the need to supply sawmills and processing mills immediately, but also to retain vigorous, healthy, vigorous, high quality trees for future generations, for the next time you'll come back in the same forest. And this balance is very hard to find, especially when you don't have processing pathways for low quality wood. I said there were two things to notice. So the first thing is that there's no clear cuts, and I cannot remember which was the second thing. Maybe it'll come back to me. Okay, so here, what we are looking at, so imagine that we are in this stand and we're looking at several stands like this, and we're looking at the relationship between, on the y-axis, the product value for a sawmill. So that's the revenues of the sawmill compared to its total cost. And what we see is that there are a lot of forest stands that are very near to the margin of profit, so that some even are below. So some of them, if you look at them, you would see that in our forest estate, we do have a large part of our forest stands that do not have characteristics that will allow us to expect a profit when they are harvested, if we look at the problem from a sawmill standpoint. And of course, so that what that means is that creates a bias for those stands that generate high profit. And of course, if you conduct bad choices in the trees to harvest and the trees to leave, what can happen is that you start with forest stands that can generate high profit, and then over time you might deplete your forest and make it go more towards those types of stands that will generate a lot less profit, and where actually the application of state-of-the-art silviculture that have a balance between the need to supply sawmills and the need to retain high quality timber, it becomes almost unapplicable, because you wouldn't force anyone to lose money into forest management, right? You cannot force a sawmill to go into the forest and apply a silviculture that will lose money. So what will happen is that the stand will not be managed, and it will be part of the unharvested part of the allowable cut. So that's the issue. When we looked at the problem, what we saw so if we look at those stands, we looked at the problem in this study by Mariana Hasegawa, she's a Brazilian student that just left my lab. I understand that there's a lot of researchers from Brazil in your research center. So she did a really good job looking at the profit here that's generated by these forest stands. And what I would like you to notice here is that the steepest line that we have on this graph is the line of the value of the co-product. So basically, the most sensitive part, so what's the most determining point in terms of viability of state-of-the-art silvicultural practices here, is the value of co-products. So here we're talking about the pulp logs. So do we have a market for pulp logs? If we have a good market for pulp logs, we are very likely to generate a lot of profit, and in doing so, we're likely to be able to apply state-of-the-art silvicultural practices that will ensure that we have a healthy, resilient forest estate. So in our work, we started to look at how could we then, in the case of hardwoods, how could we then add value to what we are currently harvesting? And that took various forms, and I'm just listing here a series of 3 studies, but there were lots more than that were conducted well, through a collaboration, mainly in this case with Tatiana Stevanovic, who's a colleague of mine, but also I think former supervisor of Jean-Michel. And so she led different studies in which we're trying to identify potential molecules that can be valued from either the wood or the bark of the trees, the hardwood trees that are harvested. And there's a plethora of molecules, and you know probably a lot more about that than me. And we identify some promising ones, such as, for example, just one example is betulin. And in our studies, so Mariana kept on going with her studies, and what she found with betulin is that you could actually increase the value of your harvest, but the issue with that is that it generates a very limited demand for biomass because of the nature of what is being valued. You rapidly saturate your market. So in thinking about that, we knew that extracts might not generate that much of a demand for biomass. So what about bioenergy? And so we developed different, in this case, we envisaged pellets. So this is the pellets that were treated by just a hot water treatment prior to the pelletization process. And so we see different hot water treatments here. The pellets do change in appearance. They become a lot more resistant to water. They are also of higher quality in terms of mechanical performance. You can also see that the energy content through this process of the pellets is actually increased. And we even saw that low vigor and low quality trees were more suitable for conversion into solid biofuels because of their higher lignin and extractive contents, mainly because of the presence of decay and the type of decay that will preferentially target the cellulose. And so so that's one example, but it remains that if we look at it from a forest management perspective, this is a nice solution, but it's not really picked up at a large scale, and it's wood pellets, especially for hardwoods, have not really created a very large demand for biomass either. But still, it's a nice application. If we look at the second case I've been talking about in terms of dead trees, you might be wondering why I insist so much on dead trees, but the thing is that throughout the world, dead trees are becoming more and more abundant. And this is the case also in Eastern Canada. And the problem with dead trees is that they will eventually be wasted, but also not only be wasted, the carbon they contain eventually will come back to the atmosphere. And it will therefore create a higher proportion of CO2 in the atmosphere. And the IPCC has thus recognized that the issue, and has thought that in the development of bioenergy as a solution to fight climate change, maybe a preferential source of feedstock for bioenergy products should be those dead trees, because they're abundant over the world. And eventually, when you harvest those trees, you're not harvesting a live trees that will keep capturing CO2 through photosynthesis. You are actually harvesting a tree that slowly in time will return its carbon to the atmosphere. So this is key here. The IPCC, that's the International Panel for Climate Change. So that's a large body of scientists around the world that have identified that as a primary key source of feedstock for biomass, for bioenergy. And here in another study, so what we looked at is, okay, so if dead trees can fuel the bioenergy sector, that means that we need again to look at whether it's possible financially. So we know that when trees, we've said before that when trees have spent more than 4 years standing after they've died, they are likely to have much lower lumber value. But the thing is that not only lower value, but also, not only lower lumber value, but also they will have lower value for pulp mills. They do not like having drier chips with decay and color. So for pulp mills also it's a problem. So we asked the question, what if we could process those lumber byproducts into pellets instead of chips for pulp? And so here, let's compare those without getting into the details. Let's just compare those two scenarios. So here you have the business as usual. You have a dead tree within 4 years that will have retained its bark. You harvest the tree for lumber, and the byproducts go for pulp in terms of sawdust and chips. And in the other case, in scenario 2, you would replace the pulp by or the chips for pulp. You would replace them by sawdust and wood chips that would eventually be processed into pellets. When we look at that, this is again at a financial examination of this, and on the x-axis you still have the size of the stem here, so that's the diameter of the stem. And most of our stems are here in the lower part of this curve. And if you look at the difference, well, if you look at the profit, basically on the y-axis, you're looking at the profit. And of course, you're making higher profit if you have bigger trees, that's for sure. But what I'm trying to show here is that the difference between the blue line, so that's our second scenario where we produce pellets instead of chips for pulp, is not quite as good. It's close, but it's not quite as good as the scenario in which the sawmill produces chips for pulp. So even in less than ideal conditions, the pellets still have too little value to beat the business as usual scenario. Okay, so that's the so what does this come to? In short, we are looking for solutions for that. That's the part of my research program, but also that of my colleagues, in which we are in a rapidly changing social environmental context. Sustainable forest management requires value-added processing pathways for lumber co-products. So I could have said value-added processing pathways for low-quality wood, low-quality timber, to try to avoid having this bias towards the most high-quality trees for lumber, which also happen often to be the most vigorous trees and the trees in which the forest stands in which it's easier financially to apply state-of-the-art silviculture. High value-added solutions, but here's the problem. High value-added solutions, such as extracts, for example, they typically yield low demand for biomass. Conversely, processing pathways yielding high demand for biomass typically have low added value. So it becomes an engineering problem, and one that as you can see from my research, I do not have the skills to try to fix entirely by myself. So we need people like you guys to put to try to develop new processing pathways which will both generate high value added and generate high demand for biomass. And for this, I think we need, for this to succeed and have an impact on the quality of our forest management and the quality of our forest estate, I think we do have to take a holistic approach. So this is all about joining forces, and we've done it to some extent in Matériaux Renewable Québec. So as you can see, we have people from different backgrounds in forestry and wood science looking at how we can try to make the overall forest value chain more profitable, better able to apply state-of-the-art forest management. And so this is something that we are doing together. As Jean-Michel said, you are already part of this. This is actually a picture from the 12th of March 2020. So that's the last day before confinement, where we had a room full of people just before everything was shut down in Quebec. Luckily, we were able to hold the meeting. Even more luckily, we were none of the participants became contaminated with the virus. Since then, we've been working, of course, at a distance, so we keep our activities. This is an example where we call it the innovation space, in which we submit a problem and we try to propose a solution in a rather short period of time, to try to trigger innovation in the forest product sector and trigger knowledge transfer, and also to try to generate opportunities for projects that we run in common. So all of this is meant to be a call for action. So you've seen the problem I've been trying to describe, and to some extent, what I wish to say is that whereas I consider that I do have some understanding of the problem at its source, so the problem of forest management at its source, I think we also have had interesting potential solutions that we've started to develop. But actually, to be able to have a real impact, I think we need to join forces with people who have a much larger capacity, such as you guys, to develop new value-added products for low-quality timber. So a few points to make here. MRQ is a 3-year program that's being funded by the Fonds de Recherche du Québec, Nature Technologie. It will run until 2022, and most importantly, it will not be renewed. It's a one-off. In the meantime, we could do great things, I think. We invite you as researchers to take part in our activities, but also take advantage of our support programs, mainly in the form of scholarships, but also support for students who are willing to complete their studies, or students that wish to produce material for technology transfer, knowledge transfer, but also invite you to think about what's next. And one thing I could see is that we could try to head towards regroupement stratégique from the FRQNT. I think we have quite a few success stories that could lead us in that direction, and that the group that's part of MRQ today maybe should consider consolidating its structure so that we are more agile in reacting to calls for funding from the different funding agencies such as NSERC or FRQNT. On that, I will thank you for your attention. I hope I've been able to stimulate your thoughts. All the references that were included in this presentation are at the end of my presentation, which I can leave to Marie. And on that, I will stop sharing my screen, and I'll be happy to answer your questions.
Questions, guys? Professor Achim, I have a question for you.
Yes.
I heard that you are going to work with extractives to produce high value added products. Why did you choose extractives and not cellulose or hemicellulose?
It's a good question. So there's two elements, I guess, in that answer. First is the fact that, I guess, cellulose itself, there's already uses for cellulose. I consider that, you know, that especially in a region like where you are, pulp and paper still are a key solution for adding value. You know, it ticks all the boxes. It adds value to the resource and creates a great demand for biomass. So that's the first part, and I guess that then the issue becomes more about hemicelluloses and lignin. So, which brings me to the second part. And I guess that in our research center, we have I guess we have only a single researcher who actually works on these issues, and it's Tatiana Stevanovic. So our expertise in terms of biorefining is very limited at Laval University. We have been mainly focused on processing solid wood, which is also an important part. I think you'll agree with me. Developing solutions, up to building with wood, building high-rise building with wood. But I think that's the idea. I think that's our core strength is this, and we need to get associated with other groups such as yours, or the group in Trois-Rivières, or the group in McGill, or Polytechnic, or whatever, to try to find solutions for hemicelluloses, lignin, or even cellulose.
Thank you, Professor. I have another little question because I am curious, because you talked about timber quality. So how do you measure the quality of a tree for lumber? Because I don't know.
Okay.
Sorry.
Yeah, that's a very good question. And in fact, yeah, the concept of quality is always something that is relative to it's relative to what we envisage as an end product, right? So in the case of lumber, quality of the lumber piece itself will be associated with its mechanical properties, with the absence of defects such as knots, such as decay. But perhaps more importantly to the forest industry throughout our projects, what we've seen is a very clear indication that quality for our forest stand. So if we go to a wider scale, quality will mean a high proportion of conifer trees within a forest stand, so very little hardwoods, because we do not have the processing pathways for those in many regions. And second, good dimensions. As you can see, the profit were increasing very high, very rapidly with the size of the timber that was being harvested. So one limiting factor in the quality of our stems from the boreal forest is their size. So if we can have decent size, I'm talking about 25 centimeter trees and forest stands that are primarily consist of softwoods, conifers, then that would be considered a high quality stand for lumber very often. And for hardwoods lumber, then in this case we need highly vigorous trees with the absence mainly of decay. And of course, and that brings me back to the second point that I've forgotten, so that in the best case scenario, in a hardwood stance, you will have at least 50% of your volume that will not be of a sufficient quality for lumber. So that means that even in the best stand of hardwoods, you will have 50% of your volume that will be that cannot be processed as lumber. So what we need is, again, those processing pathways. And as I said before, pulp and paper is a very interesting processing pathway. It ticks all the boxes, but it seems that we need more, because there are regions in Quebec and in Canada and throughout the world where we do not have those pulp and paper mills for softwood products.
Thank you, Professor Achim. Guys, do you have questions?
Yeah, I have one. This is Jean-Michel speaking. So at this point in time, Alexis, how much are you quantifying the price for transportation for lumber or wood per kilometer, per, let's say, cubic meter, or per ton? How much does it cost at this point in time to transport wood? You know that?
That's a very good question. No, I don't know. I don't know. I would have to defer that question to people in the FORAC consortium that are more that work more into the forestry wood chain as industrial engineering problem. So I cannot remember. I used to know the numbers, but I can't remember. Sorry.
Fair enough, because I have numbers that I like declined from 1988 with the price of oil, and I am not like completely confident on those numbers. I just wanted to say from an expert if you had better numbers, but okay, that's fine. Other question I had for you. You talk about silviculture, yeah, and is there any modification to the way things are being done by the forest engineer at this point to avoid having those pure breeds, those crops that attract disease or even create disease? Because as you might know, in the West, they had this spine beetle thing that stimulated quite a lot the pellet industry. So those guys were rich for a while. And
Yeah.
because of those crops. So is there still this tendency to make crops in the forest sector, or is it being put aside since, well, we have more and more proof that it's not like great?
Yes, well, it's a huge concern right now for forest engineers. So what we are setting up now is a consortium throughout Canada where 14 different partners have joined forces together from government and industry and even community partners across Canada, trying to look at those questions. How do we make the forest more resilient, more resistant to this changing environmental context? And so yes, the answer is yes, we are looking at how things could be changed. Now, in Quebec, we have a situation where naturally we have a very, very large forest estate that's dominated by a single species, that's black spruce, right? So it's not likely to change overnight. And of course, if something were to happen to black spruce, it would be a complete disaster. Now, touch wood, it's not a problem thus far. It's not been a main problem thus far, but transforming such a huge forest estate into more of a mixed forest estate is going to take a huge amount of time and some effort, of course. And then we still have the same problem that, you know, what could grow with those black spruce trees in the north would be, again, those mixed stands, so that we could decrease the vulnerability to fire, for example, by having more hardwoods in our coniferous forests. But if we do so, then we come back to the same problem of having to find suitable pathways for those softwoods. So I think that yes, we will try to increase the resilience and the resistance of forest ecosystems over time to disturbance. But we need to look at it in a holistic way and try to develop those, developing those processing pathways for hardwoods, for low quality hardwoods, it will only help making that change.